All right, so we are going to use basic identities for this part 2 solving trig equations video. The basic identities, two things that you need to have out with you in order to identify the basic identities. You need to have your reference sheet out, which should be the first page of your packet. You also need to have your unit circle because we are going to pull answers off of that unit circle. So the basic identities that we are going to look at for 15, 16, 17, and 18 are the reciprocals, the quotient, the Pythagorean, the cofunction, and the even and odd identities. Those are the basic identities that we need. So in the first problem, I have cosine x minus 1 equals to sine square x. Well, what I can do is I can use the Pythagorean identity, which is sine square x plus cosine square equals to 1. I can rewrite that as sine square x equals to 1 minus cosine square. That means I can take sine square out and replace it with 1 minus cosine square, which creates an all cosine equation. It's easier to solve an equation when you can convert it to one trig function. So always look for opportunities to do that. Now, by doing that, I created a quadratic, so I'm going to have to move both of these terms to the other side so I can set the problem equal to 0. So that's going to be cosine square plus cosine x minus 2. Now, when you have a problem that has just one function in it, all cosines, even though this is square, it doesn't matter, we're going to have to factor this problem. So what I can do is I can write it as x squared plus x minus 2 without the trig function. I can factor it without the trig function. So that would be x plus 2 and x minus 1. Solve it without the trig function. And then once I solve it, I can put the trig function back. So I am going to use these two answers from my factors to find the angles involved. Okay, now the first answer that I got, -2, produces no answers because this value for sine and cosine has to fall between -1 and +1, and -2 does not fall between that or in that interval. Cosine equaling to +1, if I go to my unit circle, the only place that has an x coordinate that is a 1 is at 0 degrees. Now, the way I present my answer, I do have an infinite interval for this equation, so I do have to write that to pi n. And so my final answer would be 0 plus 2 pi n because of the interval, infinite interval. Now, I'm going to do the same thing for number 2. The only difference is I'm going to use a different Pythagorean identity to create an all cosecant equation. So if you go to your formula sheet, you will see a Pythagorean identity that says cosine or cotangent square theta plus 1 equals to cosecant square theta. So I'm going to take this cotangent square out and replace it with the manipulated version of that Pythagorean identity. So I need to subtract my 1. So cotangent square is coming out, and cosecant square theta minus 1 is going in its place. Now, when I do that, I put a quadratic, or I have created a quadratic. So I need to combine my -1 and my 3. I'm not moving it, so do not add 1. You are combining -1 and 3. They are on the same side. Since I have an all cosecant equation now, I can come over here and write x squared minus 3x plus 2 equals to 0. When I factor that, I get x minus 2 and x minus 1. When I set each factor equal to 0, I get x equals 2 and x equals to 1. So I'm going to come back over here and I'm going to rewrite that as cosine theta equals to 2 and cosine theta equals to 1. Now, I don't like, or not cosine, cosecant theta equals to 2 and cosecant theta equals to 1. Now, I don't like reciprocals, so I'm going to use the reciprocal identity to turn this into sine theta. Now, if cosecant and sine are reciprocals, that means you're going to take that value, which is 2 over 1, and you're going to flip it, and it's going to become a 1/2. I'm familiar with 1/2 coordinates on my unit circle for sines and cosines. Same thing here. I'm going to do the reciprocal. Well, when you take 1 over 1 and you flip it, it stays 1 over 1. So now I need to go to my unit circle and I need to find the places that represent these values. Well, for the first one, sine is positive in the first and the second quadrant. So for this one, I cannot look to third and fourth because sine is always negative in those quadrants. My first quadrant angle that has a y value, which is what sine is, of 1/2 is pi over 6. So theta equals to pi over 6. In my second quadrant, the angle is 5 pi over 6. That has a sine value of 1/2. Now, keep in mind your interval. I can go from 0 to 2 pi, and I can't go outside of that interval. So these are the only two answers that fall between 0 and 2 pi that have a sine value of 1/2. Now, I need sine equals to positive 1. So if I go to my unit circle, the only place where sine, or the only angles that have 1 and negative 1 and zeros between 0 and 2 pi, that would be 1, 0, 0, 1. You've got negative 1, 0, which does not help me. And you've got 0, negative 1, which does not help me. I want sine theta equal to positive 1. Well, that would be up here at pi over 2. Now, I do not have to write the 2 in pi because I am on a defined interval. I do not have an infinite interval. So those are my three answers for 15, or for number 16. Now, number 17 is a little bit different because we have tangent and sine. So what we're going to do is we are going to use our basic identities to rewrite tangent as sine over cosine, and that is just a quotient identity. You have a quotient identity that says tangent theta is equal to sine theta over cosine theta. So I'm going to replace that 3 times sine theta over cosine theta. I'm going to leave 2 square roots of 3. I should be using alpha. I apologize. Let me put my alphas in so we are consistent here. All right. Now, I know it's kind of hard to see, but there is a sine greatest common factor. So I'm going to take sine alpha out. That leaves me with 3 times 1 over cosine alpha minus 2 square roots of 3. Greatest common factor is a sine. Now, I can turn 1 over cosine. 1 over cosine theta is equal to secant. So I have sine alpha times 3 secant alpha minus 2 square roots of 3. Now, I have both of my factors, so I'm ready to solve. When I set my monomial factor equal to 0, that's just sine alpha equals to 0. Here, I have a little bit more work to do. That's 3 secant alpha minus 2 square roots of 3. Set that equal to 0. So I have 3 secant alpha equals to 2 square roots of 3. Divide by 3. and I end up with 2 square roots of 3 over 3. Okay, so now I do not like secant. So what I'm going to do is I'm going to take my secant alpha equals to 2 square roots of 3 over 3. I'm going to change it to cosine. I am much more familiar with cosine than I am secant. So that means I flip this fraction. So 3 over 2 square roots of 3. That gives me 3 square roots of 3 over 6, and that reduces to square root 3 over 2. I am very familiar with a whole bunch of square roots of 3's over 2. So this changed to cosine alpha equals positive square root of 3 over 2. So the first number we're going to look for, it's a lot of work, I know. The first number we're going to look for pertains to sine alpha equaling to 0. Okay, so when I go to my unit circle, I have to consider my interval so I can give answers from pi to 2 pi. So that means first and second quadrant are out. First and second quadrant are out. So I need to find any place that sine is 0. Okay, so if I look here, that's -1, 0. Here, I've got 0, -1, and at 2 pi, I've got 1, 0. Well, your sine value is the y coordinate. So I have 2 places where sine alpha equals to 0. So that would be pi and 2 pi. Now, I have cosine alpha equaling to positive square root of 3. So when I look, cosine is always negative in the third quadrant and it's positive in the fourth quadrant. So when I go to the fourth quadrant, I need to find the angle that has the x value of root 3 over 2, which would be 11 pi over 6 in this quadrant. I can't use third quadrant because cosine is always negative. So I have 3 answers in this particular problem. Number 18, I have secant and I have tangent equals to 1. So what I'm going to do here is I'm going to say secant x equals to 1, or I should say tangent x plus 1. One thing that people don't think about doing is you can actually square both sides. So that becomes secant square x. You have to FOIL the right side, so please make sure that you take the time. Tangent x plus 1 is not tangent square x plus 1. So you have to take tangent x plus 1 and tangent x plus 1. You're going to FOIL that, so that's tangent square x. You end up with 2 tangent x in the middle plus 1. So when you FOIL this, you get the trinomial Now, I can use a Pythagorean identity because there is one that says tangent square x, or alpha, plus 1 equals to secant squared alpha. So I'm going to take secant square alpha and replace it with tangent square x plus 1. Now, I do have a quadratic, so I need to set it equal to 0, which means both of these terms are going to go to the back this time. Well, when I do that, my tangent square cancels, and that's great. And that will leave me with 2 tangent x, and that's it, because the ones will also cancel. So that means 0 equals 2 tangent x. So now I have to go to my unit circle, and I'm going to look at every point between 0 and 2 pi that has a 0 in it, which would be 1, 0. Let's see. 1, 0, 0, 1. This would be negative 1, 0, and this would be 0, negative 1. All right, so if I think about tangent, all tangent ratios off the unit circle are y over x. When I put 0 over 1, I get 0. When I put 1 over 0, I get undefined, so that doesn't work. 0 over negative 1, that's at pi. And then negative 1 over 0 is undefined, so that doesn't work. This one actually did work. Now, the problem is, do both of these answers work? Okay, now, if you plug these two answers in, this does not work. So what that would be is secant at pi minus tangent at pi should give me a 1. All right, so secant is equivalent to 1 over cosine at pi. Cosine at pi is negative 1, so that would be 1 over negative 1. So basically what I'm doing is I'm checking my answers. So this would be 1 over negative 1 minus tangent at pi is 0. And that gives me 1. Well, that doesn't give me negative 1. So pi has to be thrown out. So it's a good idea to make sure that you do check all of your answers, and you can do that very easily by plugging it into your calculator, because secant of one angle minus tangent of that same angle should equal to positive 1, and it doesn't. So my only answer here would be x equals to 0. Now, for 19 and 20, we're going to use the sum and difference formula, so make sure that you have your reference sheet with you. Okay, so this says sine alpha minus beta, so I'm going to use the formula, the difference formula for sine a minus b. So this would be sine pi over 6 cosine of beta minus cosine pi over 6 sine of beta. So what I've done is I've taken that out and I've used my difference identity. I used my sine a minus b formula off my identity sheet. Now, my cosine a minus b is next. So cosine a minus b, the formula for cosine a minus b is cosine of pi over 3 cosine of beta plus sine pi over 3 sine beta, and that is all still equal to square root of 6 over 2. All right, so now I need to fill in the gaps. So I can replace this with 1/2 by pulling it off my unit circle. So that would be 1/2 cosine beta minus, I can replace this with square root 3 over 2 sine beta. Here, cosine of pi over 3 can be replaced with 1/2 cosine beta. Sine at pi over 3 can be replaced with square root 3 over 2 sine beta. And that is equal to square root 6 over 2. So as I go across 1/2 cosine beta minus 1/2 cosine beta, when I combine like terms, that cancels. Negative square root of 3 over 2 sine beta minus 3 square roots of 2 over beta ends up being negative square root of 3 sine beta. When you take negative square root of 3 over 2 and you subtract square root of 3 over 2, you get negative 2 square roots of 3 over 2. and the 2's will cancel. So that's why that is negative square root of 3. And that equals to square root 6 over 2. Now, I still need to get rid of this, so I'm going to divide both sides by, or I need to isolate, not get rid of. I apologize for the wrong term. So the negative square root of 3 cancels, and that leaves me with sine beta. Now I have to do the division here. So I'm going to come over here and clean up some space so I can make sure everybody understands the math that's going on here. That would be square root 6 over 2 divided by negative square root 3. And that becomes 6 over 2 times 1 over negative square root 3. That becomes square root 6 over negative 2 square roots of 3. When you rationalize it, you get square root 18 over negative 6. Square root of 18 reduces to 3 square roots of 2 over negative 6. And I end up with negative square root of 2 over 2. So sine beta equals to negative square root of 2 over 2. Now, I am on a restricted interval, but I can go from 0 to 2 pi. I need to identify the quadrants where sine is negative. That's in third and fourth quadrant. The angle involved that has a sine value, which is the y coordinate in third quadrant, is 5 pi over 4. And in the fourth quadrant, it's 7 pi over 4. So my two answers are 5 pi over 4 and 7 pi over 4. So when you have to use the sum and difference formula, there is a lot of work. I should just say there's a lot of work to be done when you are solving trig equations, period. All right, so we're going to do another formula. This time we're going to do cosine sum and cosine difference. So I need to look at my identities, and I need to use my cosine alpha plus beta, and then I will use my cosine alpha minus beta for the second group. So a plus b here, a minus b here. So that would be cosine pi over 4 cosine x minus sine pi over 4 sine of x. I'm going to add, now I need to do my difference formula, which is cosine pi over 4 cosine x, and that would be plus sine pi over 4 sine x. And all of that is equal to square root of 2 over 2. Now, one thing you can do here is you can go straight across before you make substitutions. So I'm going to do this just a little bit different. Cosine pi over 4 cosine x plus another one gives me 2 of those. So I'm combining like terms before I make any substitutions. Negative sine pi over 4 sine x plus will cancel. So I end up with that square root of 2 over 2. So what I can do here is I'm going to take cosine at pi over 4 and replace it with its value of square root 2 over 2. I'm going to cancel the 2's. So that leaves me square root of 2 cosine x equals to square root 2 over 2. So I'm going to divide both sides by square root 2. So square root 2 over 2 divided by square root 2 becomes square root 2 over 2 times 1 over square root 2, and the square roots can cancel. So I end up with cosine x equaling to 1/2. Now I am on a restricted interval, so I'm going to go to my unit circle, start at 0, end at 2 pi. I'm going to identify the two quadrants where cosine is positive, which would be first and fourth. And then the last thing I'm going to do is I'm going to identify the angle where the cosine value, which is the x coordinate, is 1/2. In the first quadrant, that would be pi over 3. And in your fourth quadrant, that would be 5 pi over 3. So there are your two answers because we are on a restricted interval. So these are your final two answers. All right, now we're getting into double angles, half angles, and we're also going to do product to sum. So make sure you still have your unit circle, make sure you still have your identity sheet out so that we can go through and solve these so you can reference and look at the identities that we are actually solving for. All right, so here I have sine 2u plus cosine u equals to 3 cosine u. So first, I'm going to take sine 2u, and I'm going to move this to the other side. So that would just be cosine u equals to 0, because 4 minus 3 is just 1. Now, I do not want this in here if I can avoid it. So what I'm going to do is I'm going to look at my double angle identities, and you only have one option for sine 2u. That would be 2 sine u cosine u. So I'm going to replace that with its identity equivalent. So 2 sine u cosine u plus cosine u. I'm going to factor out the greatest common factor, cosine, and that gives me 2 sine u plus 1 equals to 0. So I get cosine u equaling to 0. Here I get 2 sine u plus 1 equals to 0. So I end up with sine u equaling to negative 1/2. So for my first one, I am on a restricted interval, so I can go from 0 to 2 pi. I need to identify the two places where my x values are 0. That would be here. My x value is a 0, and at the bottom, my x value is also a 0. So cosine u is at pi over 2, and it's also at 3 pi over 2. So I've got the answers associated, the angles associated with this ratio. Now here, I need to find where sine is negative. Sine is negative in third and fourth. So I'm going to go into the third quadrant. I'm going to identify the angle that has a negative 1/2 as its y value, which would be 7 pi over 6. And in the fourth quadrant, the angle that has a negative 1/2 for its sine value is 11 pi over 6. So I'm going to add to these answers. I'm going to add 7 pi over 6 and 11 pi over 6. So I have 4 answers. In the next problem, I have a double angle for cotangent times a tangent plus 2. So what I'm going to do is I am going to replace this with its equivalent. So you have to be very careful with the double angle formulas, okay? So this is what happens when you have a double angle formula. All right, so I know that tangent double angle is 2 tangent theta over 1 minus tangent square. If I want to change that to its reciprocal cotangent, that means I take this fraction and I flip it. So 1 minus tangent square theta over 2 tangent theta. So I'm going to take cotangent theta out and replace it with its equivalent. So 1 minus tangent square over 2 tangent times 2 tangent theta plus 2 equals to 0. By doing that, that creates an all tangent equation. Now, since we're multiplying this whole fraction by the 2 tangent theta, those will cancel. So that leaves me with 1 minus tangent square theta plus 2 When I combine like terms, I get negative tangent square theta plus 3. When I solve it, I get 3 equals to positive tangent square. And when I take the square root, I get plus minus square root 3 equals to tangent theta. Now, I am absolutely on a restricted interval, so I have to keep that in mind. So when I look at my unit circle, I can only look at certain areas or area. So my interval goes from pi over 2 to 3 pi over 2, which means I cannot look here. I'm going from pi over 2 to 3 pi over 2. That's my interval. So I'm looking for positive and negative, and that's okay because tangent is negative here and tangent is positive here. So I am going to be pulling answers from each quadrant. Now, you have to remember tangent is tricky because tangent of every angle on the unit circle is the ratio y over x. So you need to find the y divided by x coordinate that produces the square root of 3. Well, in the first or the second quadrant, that would be at 2 pi over 3. So I have theta. If you take the y value for 2 pi over 3 and divide it by the x value, you will get negative square root of 3. In the third quadrant, that angle would be at 4 pi over 3. Same thing. If you take the y coordinate and divide it by the x coordinate, it simplifies down to square root of 3. So I have two answers, 2 pi over 3 and 4 pi over 3. Now, please make sure that you do check all of your answers so that if any of them need to be eliminated, you can eliminate them. All right, so now we're getting into two examples where half angles are used. So what I'm going to do in this particular problem is I am going to square both sides of this problem. So I'm going to square both sides. So that gives me cosine square x plus 4 cosine x plus 4 on the left when you factor it all out, and sine x over 2 squared, okay? Sine half angle is equivalent to, where's my plus minus? That would be plus minus square root of 1 minus cosine theta over 2. Well, when you square that, the square and the root will cancel. So that gives me 1 minus cosine all over 2. By doing that, I have now created nothing but a cosine equation. And so now I can solve this. Multiply everything in the problem by 2 to clear the fraction. So that would be 2 cosine square x plus 8 cosine x plus 8 equals to 1 minus cosine. Since we do have a quadratic, let me go back and put the right variable. Since we do have a quadratic, I am going to move both of those to the other side. So that's 2 cosine square x plus 9 cosine x plus 7 equals to 0. So now I have to factor 2 cosine square plus 9 cosine plus 7. So over here, since it's nothing but cosine, I'm going to take cosine out. I'm going to work with a format that I am more familiar with, solve it, and then come back over here and put cosine back in. Now, when you factor this quadratic, the factors you should get should be 2x plus 7 and x plus 1. That would give you 2x and 7x, which is 9x total. So from here, I get x equals to negative 7 over 2. And here, I get x equals to negative 1. So I have cosine x equaling to negative 7 over 2, and I have cosine x equaling to negative 1. Now this answer gives me no solutions because this number always should fall in the negative 1 to 1 interval, and it does not. Here, I need to consider my restrictions, so 0 to 2 pi. I need to find out where cosine is negative 1, and the only place that has a negative 1 as its x value is at pi. So x equals 2 pi is the only answer that I get for that half angle problem. All right. In number 24, I'm going to go and grab my half angle formulas. Tangent half angle has 3 variations to it, and I am going to use my favorite variation, which is the one with the monomial denominator. So when I look at my reference sheet, tangent half angle has 3 formulas, but the one I'm going to use is the 1 minus cosine over sine. So I'm going to take 1/2 and I am going to multiply it by 1 minus cosine A over sine A. Now, cosine square alpha. If cosine alpha over 2 is equal to, you only have one option, plus minus the square root of 1 plus cosine alpha over 2. If you square both sides, you get cosine square alpha over 2 equals to 1 plus cosine alpha all over 2. So I'm going to take this out, and I am going to replace it with 1 plus cosine alpha over 2. Now, cosecant, don't want cosecant, so I'm going to replace it with 1 over cosine alpha. And all of that is equal to 1. So cosecant is not that. Cosecant is 1 over sine alpha. I apologize. Now, if I multiply here, I get 1 minus cosine alpha over 2 sine alpha. If I multiply here, I get 1 plus cosine alpha over 2 sine alpha. And that equals to 1 still. Now, since I have common denominator, I can combine the fraction to 2 sine alpha denominator. 1 minus 1 cancels. Negative cosine A minus cosine A gives me negative 2 cosine A. That gives me negative cosine over sine equals to 1. That gives me cosine A over sine A equaling to negative 1, and that would be cotangent A equals to negative 1 because cosine over sine is equivalent to cotangent. Now, I don't like cotangents, so I'm going to use the reciprocal, and I'm going to change that to tangent A equals 2. If I take negative 1 and put it over 1, when you flip it, you still end up with negative 1. So now I have to consider my interval, which is pi to 2 pi. So I am absolutely restricted. So on my circle, I am restricted from pi to 2 pi. So nothing in the first or the second quadrant is fair game for this particular answer. Now, you have to remember tangent is positive here and it's negative here. So even though my restriction is from pi to 2 pi, I can't use the third quadrant either because I have a negative tangent value. Now, if you recall, and I've said it a couple of times already in this particular video, that tangent of any angle on the unit circle is y over x. Well, the only set of coordinates that you take the y and divide it by x that gives you a 1 would be at 7 pi over 4, because that is your square root of 2 over 2 and your negative square root of 2 over 2 point. So my final answer for this particular problem is 7 pi over 4. Now, the last two problems use the product to sum identities. So please make sure you have the product to sum identities handy. So what we're going to do is, this is a difference, sine minus sine. So we're going to grab the sine A. We're going to use the sine A minus sine B of sum to product. So I'm going to do 2 cosine theta plus 3 theta over 2 times sine of theta minus 3 theta over 2, and all that equals to 0. So 1 plus 3 is 4. 4 divided by 2 is 2. So 2 cosine 2 theta. That's going to be 1 minus 3 is negative 2. Negative 2 divided by 2. That's going to be sine of negative theta. Now, I have a double angle formula. All right. So what I'm going to do is I'm going to replace it with one of its equivalents. Cosine double angle has 3 variations to it. So what I'm going to do is I'm going to replace, I'm sorry, I should not put that all the way around there. I'm going to replace cosine double angle. So the 2 is already there. The cosine double angle formula that I'm going to use is 2 cosine square minus 1. Now I'm still multiplying. Here I'm going to have to use my even or odd identity, which tells me sine of negative theta is equal to negative sine theta. So I end up with 4 cosine square theta minus 2. All of that is being multiplied by negative sine theta. Now, you have factors. Do not distribute the negative sine theta. I'm going to set up 4 cosine square theta minus 2 equals to 0 and solve it. Negative sine theta equals to 0 and solve it. Here, this one's the easier of the two because you divide by negative, you still get 0. Here, I have 4 cosine square theta equals to 2. Divide by 4. And that gives me, I'm going to leave it as 2 over 4. And when I take the square root of it, that gives me cosine theta equals to positive and negative square root of 2 over 2. All right, so I am looking for places where sine theta is 0 and cosine theta is positive negative square root of 2. I am on a restricted interval. I can go from 0 to pi, which means I do not look at third or fourth quadrant. So sine being 0, that means the y coordinate. So I have 1, 0 here, and I have negative 1, 0 here. So for this one, theta is equal to 0 and pi. Cosine being positive and negative. Cosine's positive here, negative here. And the root 2 over 2 angle from first quadrant is 4 pi, or pi over 4. And the negative root 2 over 2 is negative, or is 3 pi over 4. So I'm going to add those to my list. 4 pi over 4 and 3 pi over 4. And those are my 4 answers for number 25. Okay, last one. I know it's a lot of work and it takes a lot of practice and a lot of patience. Make sure you always have your identity sheet with you and your unit circle with you when you are solving these problems. Also pay attention to your interval. Are you on an infinite interval or are you on a restricted interval? So far, most of these have been, except the very first one, most of these have been restricted intervals. So the last one on this particular lesson, we are going to still use the product to sum or sum to product. So this is cosine plus cosine. I'm going to leave this cosine over here. I will deal with that in a little bit. So I'm going to take the cosine. I'm going to use the cosine alpha plus cosine beta formula. Okay, and I'm going to turn this into a product. So that would be for this, that would be 2 cosine 2y plus 4y all over 2. And I'm going to multiply that by cosine of 2y minus 4y all over 2. And that's still equal to the cosine. I ran out of room, so please make sure you remember it's equal. So 2 plus 4 is 6. 6 divided by 2 is 3. So that's cosine of 3 theta. 2 minus 4 is negative 2. Negative 2 divided by 2 is negative theta. So we're going to have to do even or odd. And remember that is cosine theta, and I switched. These should all be y's. I apologize. Switch my variable again. And that is all equal to cosine y. Okay. Now, so I have my even or odd. That turns into cosine y, because remember, cosine of negative y equals to cosine of y. And I'm going to subtract cosine y. By subtracting cosine y and setting this equal to 0, I can factor out the cosine. All right, so here I'm going to have cosine y times 2 cosine 3y minus 1 equals to 0. So now I have my two factors. Cosine equals to 0 and 2 cosine 3y minus 1 equals to 0. So cosine y equaling to 0 is pretty easy, but cosine of 3y minus 1 is a little bit more challenging. So when we get to the second factor and we are trying to solve this, I get to cosine 3y equals to 1/2. So this one is special. Cosine at 0 or cosine y equals to 0, we can find that. But here, what I'm going to have to do is I'm going to have to kind of trick this a little bit into saying, okay, let's figure out where cosine y equals to 1/2 on the unit circle. So cosine is positive here and here, and cosine is 1/2 at pi over 6. And in the fourth quadrant, I'm sorry, pi over 3, not pi over 6. In our fourth quadrant, that would be 300, so that would be 5 pi over 3. So what I'm going to do is I'm going to say if y equals to pi over 3 and y equals to 5 pi over 3, then I'm going to set 3y equals to pi over 3 with unlimited rotations, and I'll explain that in just a second. And then I'm going to set 3y equals to 5 pi over 3 with unlimited rotations. Now, I have to divide both sides by 3, both equations. So now this gives me y equals to pi over 9 plus 2 or 2/3 in pi. Here I get 5 pi over 9 plus 2/3 in pi. So what I'm going to do at this point is I'm going to let n equal to 0, n equal to 1, n equal to 2, n equal to 3, so on and so forth. but I have to stay within my restricted values. I can only list answers between pi and 2 pi. Now, 9 is not a normal denominator that we're used to seeing on our unit circle. So what I'm going to do is I'm going to start here, and I'm going to say y equals 2 pi over 9 plus 2/3 times 0 plus pi, and that gives me pi over 9. So that is one answer because all that drops out. Then I'm going to take pi over 9. I'm going to add 2/3 times 1 pi. So 1 over 9 plus 2/3 gives me 7 pi over 9. And 7 pi over 9 falls between pi and, no, 7 pi over 9 does not fall between pi and, so I can't keep that as an answer. So second, because basically I need 9 pi over 9 to 18 pi over 9. 7 pi over 9 does not fall in that interval. So I'm going to go again, 9 pi plus 2/3 times 2 pi. Hopefully that answer will give me a number between, which is 5 pi over 9. So that one does not work. So I'm going to keep going. So I just keep going until I get above 18 pi over 9. So pi over 9 plus 2/3 times times 3. I apologize. So the 3's will cancel there. So 1 divided by 9 plus 2 gives me 19 pi over 9, which is too big. So I'm done with this one, okay? Pi over 9 actually does not work because pi over 9 does not fall. So we're going to take that one out as well. So now I start over here. So I'm going to do my 5 pi over 9, and I'm going to plug my zeros in. Now, I stopped using the first one when I got to 19 pi over 9 because that's outside of my range. So y equals to 5 pi over 9 plus 2/3 times 0, and that gives me 5 pi over 9, which is not in my interval. Y equals to 5 pi over 9 plus 2/3 times 1 pi. So 5 divided by 9 plus 2/3 gives me 11 pi over 9, and that is in my interval. When I bump up to 2 rotations, so 5 pi over 9 plus 2/3 times 2 pi, that gives me 5 over 9 plus 4 over 3, and that gives me 17 pi over 9, which is in my interval because I can go up to 18 pi. Now, if you go any further, you're going to be outside of your interval. So if you put a 3 right here, you're going to be outside of your interval because you're going to be outside of that 2 pi window. So I have now come up with the answers for this one. I do need to go back and get where cosine is 0. So cosine is 0 in 2 spots. Cosine is 0 at pi over 2 and at 3 pi over 2. Now, unfortunately, pi over 2 does not work. If you plug it into the original problem, it does not work. So these are my final answers for number 26. Number 26 is as rough as it gets. So if y'all have any questions, please make sure that you contact me and let me know if you have any questions.